right, so we have all these handy properties of vectors. They're pretty intuitive, hopefully. Vector addition is commutative, it's associative. This vector right here is called the zero vector, and that zero is bold. You could write it like this, and that is the vector that has components 0, 0. Now, graphing that is kind of difficult because the initial point is the terminal point, and it doesn't have any direction. It has no direction, and it has no magnitude. The magnitude is 0, I guess we could say. Magnitude. So this is the only vector without direction. Now, if I take any vector u, say with components u1, u2, and add that to the 0 vector, 0, 0, certainly you're still going to get vector u because you're not changing the components. All right, if I take any vector and add it to the opposite of that vector, I will get the 0 vector. And then some distributing stuff over here with scalars. And it's all pretty intuitive. It all goes along with the properties of real numbers. All right, let's try another little example here with adding and multiplying vectors. We're going to do this all algebraically here, so why don't you pause the video, give this a shot, and unpause it when you're done. All right, how'd you do? Did you get negative 257? That's what you should have should have gotten. All right, I'm just going to draw a quick little picture of what this might look like. So let's say this is the origin and I do 2u. I better start down a little bit because I got to go up 9. So let's say I go negative 2, positive 9, maybe it looks something like that. I mean, I'm just estimating here. All right, and then I do, what am I doing next? Plus 3 v's. So let's say I do v in purple. So I'm going to go 0, 16. So that's going to go over 0, up 16. Oh boy, I'm going to have to go up. Up 16. Okay, let me get rid of this. It's good to visualize what is actually happening here. And like I said, this isn't drawn to scale, but we're kind of getting an idea. So this is vector v, vector v, vector v. Now I'm going to minus u. So that would be the same as plus the opposite, which would be positive 2, negative 9. Let's do that in red. So positive 2, negative 9 would be maybe down here somewhere, something like that. So the result we'll do in lime green would look like, whoa, let's try that again. Would look like this. That's pretty close. So the components of this are supposed to be negative 257. I mean, with my rough sketch, that's pretty good. Like, you know, it's left 2, up 57. That's pretty close. Alrighty, next thing we're going to talk about is unit vectors.